This is Unit 2, Introducing Proportional Relationships, Lesson 4, Proportional Relationships and Equations. So we're going to start writing equations for these proportional relationships. And this is Activity 1. And in Activity 1, the authors want to review some mental arithmetic, some mental division, finding quotients, because you're going to do a lot of this as we go through these lessons. And so for the first one, it's 645 divided by 100. And thinking that they want you to go through, or I go through when I look at these things, is I look at dividing by 100, and I realize that that's 645. I'm going to slide each of these digits 2 place values to the right to get 6 and 45 hundredths. And then if I divide by 50, I'm dividing by something that's half the size of 100. So I'm going to get twice as much. If you're dividing some candy bars up among 100 students, if suddenly there are only 50 students, each student is going to get twice as much. So that's the relationship that they want you to see. So that means that your answer is going to be 2 times 6 and 45 hundredths. And it's going to be 12 and 9 tenths. And so now if you go down to here, 48 and 6 tenths divided by 30, look at that first as 48 and 6 tenths divided by 10, and then divided by 3. So 48 and 6 tenths divided by 10 is 4 and 86 hundredths. And then divide that by 3, 48 right there, divided by 3 is 16, which is right there. And 6 hundredths divided by 3 is 2 hundredths. So that's 1 and 62 hundredths. Now if I divide by something that's twice the size, that's half the size, I'm going to get twice as much. So now it's just like this up here. If it's half the size, you're going to get twice as much. Well, 2 times 1 and 62 hundredths, 2 times 16, so break these things up. You are mentally using the distributive property. 2 times 16 is 32, and 2 times 2 is that 4 hundredths right there. So you get an answer that's twice as large, but now if I divide by something that's twice as big, I'm going to get an answer that's half the size. So this is dividing by 15 right here. And now if I divide by 60, so something that's twice as big, I'm going to get half the size. Well, half of 1 and 62 hundredths, half of 16 is 16 tenths, is 8 tenths. And half of 2 hundredths is 1 hundredth. So it's going to be 81 hundredths. All right. That's pretty quick. I still can't resist going into some detail of the thinking, but let's go into this in even more detail. If you want to skip over the next part, you certainly may. But I'm going to go into some detail because students are, they're expected to know this stuff, and it is hard. It's hard to mentally go through this stuff and have all this stuff in your head. So I'm going to go through the thinking that I go through very rapidly. I'm going to go through that thinking slowly. So 645 divided by 100 is the same as 645 times 1/100th. So I'm going to multiply. I'm going to use the inverse operation. So I'm going to multiply, and I'm going to use the multiplicative inverse, which is 1 over 100, or 1/100th. Just because it's easier for me to visualize 1/100th of something, 1/100th of 645. It's just easier for me to see it, easier for me to think about, rather than dividing 645 up divided by 100. Either way is okay, but you're going to see in a moment that I'm going to continue using this fraction. All right, and the multiplicative inverse is also known as the reciprocal. All right, so now I have 645 times 1/10. Well, that's 64 and 5 tenths. So I'm doing this so that you see that you're sliding the digits over 1 place value to the right each time you multiply by 1/10. Most teachers will say, hey, just move the decimal point. Problem with that is that the decimal point does not move. It just stays in the same spot. It is the digits that move. And the more you talk about this, the more students will understand the idea of place value. So you're moving digits. You're not moving the decimal point. So move each digit one place value to the right. That's 64 5/10. Multiply it by another 1/10. That's a total of 1/100th. So move the digits one more place value to the right. So it becomes 6 45/100. All right, so 645 divided by 100 is 6 45/100. And here's the thinking behind that. All right, the next step was to divide it by 50. So you're going to divide by half as much. So you're going to get 2 times the amount. So I'm going to go through and I'm going to show you some thinking behind that. So I'm going to get 2 times 6 45/100. So I'm going to use the distributive property. I'm just mentally going to do this quickly in my head. 2 times 6 is 12, and 2 times 45/100. You might know that 2 times 45 is 90, so 2 times 45/100 is going to be 90/100, which is the same as 9/10. Just lots of little teeny things going on all the time as you do this arithmetic. So this is 12 9/10. And if that's hard for you to see, you can split out the 45/100 into 4/10. 2 times 4/10 is 8/10, and 2 times 5/100, the 5/100 right there, is 1/10. Add them together, and that's the same as that 9/10. The reason I'm doing this is to show students different ways that they can do these calculations in their head. All right, a check of this. We start off with looking at 645 divided by 50. That's the same as times 1/50th. All right, so I'm going to look at 1/50th as 1/10 times 1/5. That way I can use this 1/10. 645 times 1/10 is 64 5/10, and 1/5 of that. So I'm going to break this 64 5/10 up into 2 numbers that I can divide by 5 easily. 60 I can divide by 5. That's a multiplication fact. 5 times 12 is 60. And 45 is a multiplication fact. 5 times 9 is 45. So 60 times 1/5 is 12. And 4 5/10 times 1/5. Look at this as 45/10. 1/5 of that, or divide by 5, is equal to 9/10. So you get the same answer, 12 9/10. So that's a good check. All right, so this last half of this is everything on one page. I'm going to give this to you as a PDF, so you have this as a single page. So let's go through this part now. So 48 6/10 divided by 30. So again, I'm going to multiply this times 1/30th. And I'm going to break that 1/30th up into 1/10 times 1/3. 2 numbers that are easy for me to work with. 48 6/10 times 1/10 is 4 86/100. And I'm going to multiply that times 1/3. Well, I know what 48 divided by 3 is. 48 divided by 3 is 16. And 6 divided by 3 is 2. So I'm going to break this up into 4 8/10 times 1/3. It's the same as 48 divided by that 3. And 600 times 1/3. Well, 4 8/10 divided by 3, or 4 8/10 times 1/3, is that 1 6/10. So you just have to understand where the decimal point goes. If it's 48/10 and divide that by 3, it's going to be 16/10 as your answer. And 600 divided by 3 is 200 as your answer. Put them together and you get 1 62/100. So now, if I divide by a value that's twice as big as 30, that's going to be divided by 60, I'm going to get half the size. My answer is going to be half as much. Or if I divide by a value that's half the size, so 15, I'm going to get an answer that's twice as much as 1 62/100. That's what they want you to see. So 48 6/10 divided by x, where x is either twice as big, so 2 times 30 is 60, or x is half the size. 1/2 times 30 is 15. So if I divide by a value that's twice as big, I'm going to get half as much. So 1/2 of 1 62 hundredths. So I'm going to go back up to the answer. 1/2 of 1 and 62 hundredths. I'm going to break this up into two parts. 1/2 of 16 is easy for me to do, and 1/2 of 2 is easy for me to do. So 1/2 of 16 tenths is 8 tenths, and 1/2 of 2 hundredths is 1 hundredth. Add them together, you get 81 hundredths. And if I divide them by a number that's 1/2 the size, I'm going to get an answer that's twice as big. So 2 times 16 tenths plus 2 times 2 hundredths equals 2 times 16 tenths is 32 tenths. 3 and 2 tenths is 32 tenths. The reason I'm saying it that way is I want you to see that's 2 times 16. It's 32 tenths. And 2 times 2 hundredths is 4 hundredths. Add them together, you get 3 and 24 hundredths. So here it is all together on one page. And here it is just quickly doing it mentally once again. So let's just go through this one more time. 645 divided by 100 is 6 and 45 hundredths. Now I'm going to divide by a number that's half the size. I'm going to get twice as much. So 2 times 6 and 45 hundredths is 12 and 9 tenths. 48 and 6 tenths divided by 30. I'm going to get an answer of 4 and 86 hundredths. That's 1 tenth. So 1/30th is 1 and 62 hundredths. Divide by a number that's half the size. I'm going to get an answer that's twice as big, 3 and 24 hundredths. Or divide by a number that's twice the size. I'm going to get an answer that's half as big, or 81 hundredths. This is activity 2 of lesson 4, proportional relationships and equations. So we're moving towards writing the equation for these relationships. So how do you do that? So in this first part, you're given a table that compares the number of cups of dry rice to the number of people. And then you have to fill in the table, and you're going to have to write the equation in the end. And so if you start, you have, they always have to give you one of the relationships so that you can figure out the constant of proportionality. So that's one of the rows always has to be completed for you. In this case, it's the second row. And they're telling you that the relationship between the amount of dry rice and the number of people is 2 cups of dry rice for 6 people. So what do you multiply the 2 by to get to the 6? Whatever that factor is, that's the constant of proportionality, and you're going to use that all the way up and down the table. In this case, it's times 3. Well, you can see that. Everybody knows that 2 times 3 is equal to 6. But what if it was not that easy to see that it's times 3? How would you figure out this constant of proportionality? Well, you would take the value for y and divide that by the value of x. That tells you, it's up here, how many times different is y compared to x. Now I'm using the word different because if that factor is greater than 1, that would mean in this case that the number of people is greater than the number of cups of dry rice. If that factor is less than 1, that would mean that the number of people is less than the number of cups of dry rice, or that it's a fraction of the number of cups of dry rice. So in this case, that factor is greater than 1, so it's 3 times. How many times different is y compared to x? It's 3 times greater. So you divide y by x. 6 divided by 2 is equal to 3. And I'm going to do this a lot. I'm going to point to that y, and I'm going to say that tells me that y is 3 times greater than x. And that's going to help me write the equation. It's going to tell me that y is equal to 3 times x. So 6 is 3 times greater than 2. That 6 right there is 3 times greater than 2. So you need 3 of these 2's. 3 times those 2's equals 6. So 6 is 3 times greater than 2. 3 times 2 is equal to 6. All right, so that's the constant of proportionality, and you're going to use that up and down the table. 1 cup of dry rice will serve 3 people. 2 cups serves 6 people. 3 cups serves 9 people. 12 cups, 36 people. Now 43 times 3, I don't know that off the top of my head. These others I did know. So it's our multiplication facts. But I do know that 3 times 40 is 120, and 3 times 3 is 9, and just add them together, that's 129. And finally, whatever value you have for cups of dry rice, you're going to multiply that number times 3. It's going to tell you the number of people that you can serve. So that means that the number of people served, P, is equal to 3 times R, 3 times the number of cups of dry rice. So notice that the number of people served is greater than the number of cups of dry rice. So the number of units of people is greater than the number of units of dry rice. So it's 3 times greater. So the number of people served is 3 times the cups of rice. And here's a little drawing over here. This is actually using a scale factor of 5. So it's as if I had a row down here that said cups of dry rice is 5. So 5 times 1 is 5. 5 times 3 is 15. If I want to look at it as the constant of proportionality, I'd multiply 5 times cups is equal to 5 cups, and I'd go down to the 5. That would tell me that I'd have to multiply this 5 times 3, 3 times 5, to get 15. Subtle difference, and when I drew this, I didn't really mean to use the scale factor, but in fact, that's what I'm doing here. And you're going to interchange these two oftentimes as you go through these problems. You're going to check your work sometimes by using the scale factor, or the other way, you're going to check using the scale factor. You're going to check that work by using the constant of proportionality. So you will flip back and forth, but we really want students to move towards using the constant of proportionality, because that's going to get you to being able to write the equation, which opens up a whole different area mathematically. The second part of this activity is to look at spring rolls compared to the number of people. And again, they always have to give you a row, complete a row, so they tell you the relationship. So the number of spring rolls is 6 spring rolls. That will serve 3 people. So notice now that the number of people is less than the number of spring rolls. So that constant proportionality is going to be a fraction. So how many times different is less than? So it's going to be a fraction. It's going to be less than 1. It's going to be that constant of proportionality. So how do you figure out what that constant of proportionality is if you couldn't just see it? Now you can see that 6 times 1/2 is equal to 3, but what if you couldn't? Well, you take the value for y, 3, and divide that by the value for x, 6, and that tells you that 3 is 1/2 of 6. So 1/2 times 6 equals 3, or 3 is 1/2 of 6. So 3 is 1/2 times less than 6. It takes 1/2 of 6 to equal 3. So just going through these relationships and writing this out will help you understanding of what's going on. So now once you've identified the constant of proportionality as 1/2, then you can use it up and down this table. 1 times 1/2 is 1/2. So if you have 1 spring roll, you can serve half a person. 6 spring rolls, 3 people, 10 spring rolls, 5 people, 16 spring rolls, 8 people, 25 spring rolls is 12.5. So 1/2 of 25, I just broke it up into 1/2 of 24, 24 times 1/2, plus 1 times 1/2. So that's 12, 24 times 1/2 is 12, 1 times 1/2 is 1/2. Add them together, you get 12.5. Down here, number of spring rolls, you multiply that number times 1/2. That's going to tell you the number of people that you can serve. So the number of people served is 1/2 times the number of spring rolls. So P, the y value, equals 1/2 R, which is the x value. So the number of people served, P, is 1/2 times the number of spring rolls, R. So the serving size the serving size is 2 spring rolls per one person. I don't know why they didn't include that up here. Why didn't they say number of people is 1? That's going to give you the serving size. Number of spring rolls you need for one person is 2. And that, by the way, you're going the opposite direction. So you're multiplying by the reciprocal of 1/2. So 1 person times 2 would equal 2 spring rolls. So the serving size is 2 spring rolls per one person. All right, so how are these tables different? In table 1, y is 3 times greater than x. So the number of people served is 3 times greater than the cups of rice. So the constant of proportionality is greater than 1. So the number of people served is going to be greater than the cups of dry rice. The constant of proportionality is a factor greater than 1. It's equal to 3. So the number of people served is going to be greater than, it's going to be 3 times the cups of dry rice. On the other hand, table 2, the constant of proportionality is a fraction. It's less than 1. So the number of people served is going to be a fraction of the number of spring rolls that you have. So the constant of proportionality is a factor less than 1. It's equal to 1/2. So the number of people served is equal to 1/2 the number of spring rolls. So that unit is going to be less than the units of spring rolls. That unit of people is going to be less than the units of spring rolls. This unit of people, number of people, is going to be greater than the unit for spring rolls. Okay, this is activity 3 from lesson 4, proportional relationships and equations. And again, we are going to get to this idea of equations during this activity. And so a plane flew at a constant speed. They have to tell you it's a constant speed, or there cannot be a, well, say it positive. They have to tell you it's a constant speed in order to have a constant of proportionality. So they have to tell you that. Between Denver and Chicago. So it's neither speeding up or slowing down. It is going at a constant speed. It took the plane 1.5 hours to fly 915 miles. Now they choose these numbers on purpose. So 1.5 hours. When I see that, I always think of 3/2 because 1.5 is 3/2. And then I think about dividing up the number into 3 parts. So what are 3 equal parts of 1.5? Well, each one of those is a half. 1/2, 2/2, 3/2. And then I divide 915 up into 3 equal parts. Well, 915 divided by 3 is 305. And we're going to go over that next. But what I want you to see from this is if you use the miles per hour, you know miles per hour. It's how fast a car is traveling. You understand that. You've been around it for a long time. So just write miles per hour, and that tells you what the y value is. It's miles. And what the x value is, that's hours. So miles per hour. So 915 divided by 3/2. So how do you figure that out? All right, so it's 915 miles. It takes 1.5 hours. So I think about dividing both of these values up into 3 equal parts. So 1.5 hours, that's 3/2. So 1/2, 1/2, and 1/2. So 3 times 1/2. And 915 miles, again, they choose this number on purpose. You can divide 915 easily by 3. So 900 divided by 3 is 300. So it's 300, 300, 300, and 15 divided by 3 is 5. So it's 305 miles, 305 miles, and 305 miles. So the constant of proportionality is how far the plane travels in 1 hour. So it's 305 plus 305. It's 2/3 of that 3.5. So it's going to be 610 miles. So let's go through this a little bit more. So miles per hour, when I see that, I think of miles per hour. It tells me this is the y and this is the x. So 915 divided by 3/2. So then I would write it this way. 915 divided by 3/2. And you know to do this calculation, you use the inverse operation and you use the multiplicative inverse, also known as the reciprocal. You have to use both the inverse operation and the inverse of the number in order for it to make sense. So it's 915 times 2/3. Well, to figure this out, what do? Well, you divide 915 by 3. So 915 divided by 3, that equals 305. And then you need 2 of those thirds. So 915 divided by 3, and then you need 2 of them for 2/3. Well, 2 times 305 is 610 miles per hour. Now, of course, I could have just told you or shown you, divide 915 by 1.5 and you get 610. But the understanding is going through these activities in a variety of different ways, and especially using fractions. Think of it as practice using fractions. You will improve your understanding. Students will improve their understanding. All right, so the table. They give you time, and they give you one row. They always have to give you one row, one to tell you what that relationship is. And then you're to figure out the rest of them and figure out the speed for each one of these. Well, it's 915 miles per 1.5 hours. We just did this. 915 divided by 3 halves times 2/3. 915 divided by 3 times 2. 915 divided by 3 is 305 times 2 is 610 miles per hour. So its speed in miles per 1 hour is 610 miles per hour. Once you know that, that's the constant of proportionality. Once you know that, each one of these times can be multiplied by that constant of proportionality, because it tells you how far the plane travels each hour. So for 1 hour, 2 hours, 2.5 hours. So you multiply each of these by 610, and this tells you the distance the plane travels. Now, I did a little bit of extra math in some cases. 610 times 1/2 times 3, that's times 3 halves. What's 1/2 of 610? 305 times 3 is back to the 915, if you want to reverse what we had done. 2 times 610. 2.5 times 610. Well, 2 times 610 we did right here. It's 1,220. And you know that 1/2 of 610 is this 305 up here. So 1,220 plus 305 equals 1,525. And so then if you take each of these distances, 915, 1,220, 1,525, divide them by each of the times, you will get the same speed per hour. You have to. It's the constant of proportionality. So you might go through and check that and ensure that you do get the same speed per hour. And finally, the equation at the end. I'm going to use it right now, and I'm going to show you how you get that equation in just a moment. So the distance is equal to 610. So every time you want to find the distance, you multiply the time by 610. So distance is equal to 610 times the time. Where's the 610 come from? That's the distance traveled per mile. I'm sorry, the distance traveled per hour. So for 3 hours, it's 610 miles per hour times 3 hours, 1,830 miles. And 3.5 hours, 610 times 3.5. Well, 3 times 610, 3 times 600 is 1,800. 3 times 10 is 30. So you might see that 1,830 plus a half times 5/10 is 305. So I broke this up into 610 times 3 plus 610 times 1/2. And you get this answer of 2,135 miles. All right, so it doesn't look like I really went through the equation other than recognizing that you're multiplying the time in each case by the constant of proportionality. So that is the equation. The distance is equal to 610 times the time. And the last thing that I want you to think about, so we've answered all the questions up here. Now I just want you to think about y over x, that's the constant of proportionality, and that's the same as the distance divided by the time. It's miles is the distance, per hour is the time. When you do that calculation, you get an answer of 610. So what does that tell you? It tells you that the units of distance are 610 times the units of time. So if you have 1 hour, the distance is going to be 610 times that 1 hour. So the units of distance are 610 times the units of time. So that gives you the equation. The units of distance are 610 times the units of time. So it's 610 times this time. So you get the equation then of distance is equal to 610 times the time. So the units of distance are 610 times the units of time. So I'm going to do this a lot. We're going to say this value is so many times this value, because that's what it is. When you do this division, that's what you are figuring out. Okay, I want to go back to 2.5 hours and 3.5 hours. And both of those numbers of hours were multiplied by 610, the constant proportionality, to get the respective distances traveled. So 2.5 hours was 1,525 miles, and 3.5 hours was 2,135 miles. And then what you do is you take those total number of miles, divide them by the hours, and you should confirm that in fact the constant proportionality is 610 miles per hour. That is the calculation that I want to look at in a little bit more detail. So here's both of them on the same page. I'm going to zoom into this one, and then I'm going to zoom into this one and go through them. So the first one, 2.5 hours, 1,525 miles. So if you divide that, 1,525 miles divided by 2 5/10, and what I want you to see is if you change that to a fraction, the calculation is really quite simple. The authors choose these numbers on purpose, and I'm going to show you that. So 2.5 is 5, it's the same as 5 halves. So now you're going to divide by 5 halves. 1,525 divided by 5 halves. Well, to do that division, you use the inverse operation and you use the multiplicative inverse. So you just think inverse and inverse. So the inverse operation is multiplication. The multiplicative inverse is 2/5. So now you're going to multiply times 2/5. And I keep pushing for people to divide first, then multiply. So 1,525 divided by 5. So now this is pretty easy. 15 divided by 5 is 3. That's 300. And 25 divided by 5 is 5. It's now just 2 times 305, or 305 times 2 is equal to that 610 miles per hour. In a similar way, for 3.5 hours, you travel 2,135 miles. So now you divide that 2,135 miles by 3.5 hours, and you get, or actually, first of all, change the 3.5 hours to 7 halves. So 3.5 is the same as 7 halves. 2 times 3 is 6, and that's 6 halves, plus 1 more half is 7 halves. So now you're going to divide 2,135 divided by 7 halves, and again, you're going to use the inverse and the inverse. So 2,135 times inverse of the operation and the multiplicative inverse times 2/7. Divide first. Divide by that 7 first. So 2,135 divided by 7. Well, once again, they choose these numbers on purpose. 21 divided by 7 is 300. Is 3, which works out to be 300. 35 divided by 7 is 5. So this is 305 times that 2 equals 610 miles per hour. So if you keep going through this and use the fractions, don't avoid the fractions, use the fractions, you'll get better and better and better, and you'll find that it's going to make the math a lot easier for you as you go forward. Okay, this is activity 4, proportional relationships and equations, activity 4. And in this activity, they wrote this in an interesting way. The way the authors wrote this problem is you might think that it's 8 tablespoons of honey per 10 cups of flour, because for every, another meaning for every 10 cups of flour is for each 10 cups of flour or per 10 cups of flour. So you might think that the 8 is the y value and the 10, the flour, is the x value. But that's not how they wrote it. They set the table up so that the flour is the y value and the tablespoons of honey is the x value. So they wrote it in, it's okay the way they wrote it, because you can read these either way. It's 10 cups of flour per 8 tablespoons of honey. But usually you write the y value first and then you just say per the x value. But they wrote it the opposite way. So you just have to pay a little bit of attention to that, figure it out. So y over x, that's going to be the constant of proportionality. And so the way they set up the table, they tell you that the flour, cups of flour, is going to be y, so that's f, and the tablespoons of honey, or h, is going to be the x value. Usually in problems like these, they give you the x value and you are to calculate the y value. So in this case, I have 8 tablespoons of honey. How much flour do I need? Or I have 16 tablespoons of honey. How much flour do I need? 30 tablespoons of honey. How much flour do I need? So you figure out the constant of proportionality, and you multiply by that constant of proportionality to figure out the amount of flour. So the constant of proportionality is 10 divided by 8. So 10/8 or 10 divided by 8, that simplifies to 5/4. That is the constant of proportionality. So now how do you get to using that? So understand that what they're saying, or what you are saying, is that y over x, which is f over h, flour per honey, that the amount of flour is 5/4 the amount of honey. So the units of flour are 5/4 the units of honey. So 5/4 has a number greater than 1, so that means that the units of flour is going to be greater than the units of honey by 1/4 the amount of honey. So there's going to be more units of flour. And so this tells you that the equation then, and let's go over this one more time, the amount of flour is 5/4 the amount of honey. So flour is, or equals, 5/4 the amount of honey. So that 5/4 is your constant of proportionality, and you use that down this table to figure that out. So if I zoom in to the first one, so this 8, you multiply by 5/4, that's the constant of proportionality, and I keep pushing for you to do the division first. 8 divided by 4, and you can do that. That 8 divided by that 4 is 2, and then you multiply it times 5. 8 divided by 4 is 2, times 5 is equal to 10. 16 divided by 4 is 4, times 5 is equal to 20. When you get to 30, that's a little bit more interesting, because it's useful to break up the 30 into two numbers, one number that can be divided by 4, and then the rest. Well, that's 28 divided by 4, which is 7. And then what's left over is 1/2. 2/4 is the same as 1/2. Now the 7 plus 1/2, realize that this is inside these parentheses right here. And you have to have that inside parentheses to do this problem. And so then you take the 5. 5 times 7 is that 35. 5 halves, 5 times 1/2 is 2 1/2. Add them together, you get 37 1/2. And finally, the units of flour is 5/4 the units of honey. So flour, this column, flour, is equal to 5/4 the amount of honey that you're given. So flour is equal to 5/4 honey. And then they ask you to do the calculation for 15 tablespoons of honey and 17 tablespoons of honey. So I'm going to expand these two so it's a little bit easier to see. So 15 tablespoons of honey. So how much flour is that? Well, that's the amount of honey times 5/4. So there's going to be more units of flour. There's going to be 1/4 more than 15 units of flour. So 5/4 times 15. So I keep pushing to divide by the 4 first. That'd be 15/4 times this 5. So it's 15/4 times that 5. And 15/4. And this just gets, it's it seems hard if you say it all out, but you start to just do this mentally, you'll go through this quite rapidly. So 15/4, divide that up into two numbers, one that's easily divisible by 4, and then what's left over? Well, 12 you can divide by 4. 12 divided by 4 is 3, and what's left over is 3/4. So this is 3 3/4 times 5. So that 15/4 is the same as 3 3/4 times 5. 5 times 3 is 15. 5 times 3/4 is 15/4. So now you're left with 15/4 plus, and we just changed that 15/4 to 3 3/4 up here. So you know it's 3 3/4. Add them together, 15 plus 3 is 18 3/4 cups of flour. So this 3 3/4 is in fact 1/4 of 15. The 15 is 4/4, and then 1/4 more will give you 5/4. 5/4 of 15. So keep thinking about it. Let's try 17. So again, the units of flour are 5/4 the units of honey. So honey is equal to 17 tablespoons. So the units of flour is going to be 5/4 of that. It's going to be a number that's larger than 17. So I keep pushing once again to divide by the 4 first. 17 divided by 4, and then multiply by 5. Well, 17/4, 17 divided by 4, is 16/4 plus 1/4. 16 plus 1 is the 17. 16/4 is easy to do. 16 divided by 4 is 4, and then you have 1/4 left over. So this is 4 1/4, and you're going to multiply that times 5. So 5 times 4 plus 1/4. And again, you will do this rapidly in your head. It takes me a while to go through it step by step, but pretty soon you just go through and you calculate this in your head. 5 times 4 is 20. 5 times 1/4 is 5/4. That's 20 plus 1 plus 1/4. 5/4 is 1 1/4. And so you get an answer of 21 1/4 cups of flour. So it seems long, but in fact, as you do the calculation, it's not that long. This is activity 5 from lesson 4, which is the cool down problem in the lesson. So again, you have to be a little bit careful the way they wrote this. After 2 hours, 4 inches of snow has fallen. So that is 4 inches of snow per 2 hours, because the way they set up the table, once again, they're showing you that the inches of snow is the y value and the amount of time is the x value. So it's y per x, so it's inches per hours. So that constant of proportionality is going to be the number of inches of snow per 1 hour. And then you have to figure out how many inches of snow accumulate in 6.5 hours. So calculate the inches given per time, calculate y. Usually you're given x once again, and you're asked to calculate y in these kinds of problems. So after 2 hours, how much snow gathers? After 1 hour, how much snow gathers? After 6.5 hours, how much snow gathers? And what's a general equation to use for how much snow collects on the ground? So the constant of proportionality is y over x. That is inches over hours. So y is the inches, x is the hours. Inches per hour. So inches per hours. So the row that they give you, and they always have to give you at least one row of information, is 4 inches for every 2 hours, or 4 inches per 2 hours. You simplify that or divide. 4 divided by 2 is 2. So it's 2 inches per hour. So what does that mean then? You say y over x is equal to 2. That means that the value of y, the units of y, the units of inches, is 2 times the units of hours. So y is 2 times x, or the units of y are 2 times the units of x. So y is 2 times the units of x. So y equals 2x. Y equals 2 times x. So if you use that as the constant of proportionality, 1 times 2 is 2 inches of snow after an hour. 2 times 2 is 4. This one was given to you. And 6.5 times 2, that's the one they're asking you to calculate. So 2 times 6 is 12. 2 times 1/2. 2 times 6 is 12. 2 times 1/2 is just 1. 12 plus 1 is 13 inches of snow. And in general, we just wrote this equation. The inches of snow, the y value, is 2 times the number of hours. So the inches of snow is always a number that's greater than the time in hours. So for 48 inches, for 24 hours, it's y is equal to 2 times 24. So the number of inches of snow that gathers is 48 inches of snow. All right, so let's go to the very top row. This row right up here. So now this is going in the opposite direction. So they're giving you the number of inches, and the question is, how long did it take for that number of inches to accumulate? Well, it takes half the time is half the number of inches. So you're going in the opposite direction, so you're going to use the multiplicative inverse, which is the reciprocal. Well, the multiplicative inverse of 2, and you can read 2 as 2 over 1 if you want, is 1/2. So remember, if you multiply the multiplicative inverse with the number, it's always going to equal 1. 2 over 1 times 1/2 equals 1. So if you go back in the other direction, the reciprocal or multiplicative inverse is 1/2. 1 times 1/2 is 1/2. And so if you just check with these other two rows, 2 times 1/2 is 1. 4 times 1/2 is 2. So when you go back in the other direction, you use the reciprocal or the multiplicative inverse. And what this tells you is that time, the units of time, are half the units of inches. Now you're going this way, so you're going to say the units of time are 1/2 the units of inches. You can look at this as x over y, but then it really gets confusing if you start doing that stuff. All right, I want to one more time go over the meaning of the constant of proportionality when you do that division. So if the constant of proportionality is 4 over 2, when you do that division, 4 divided by 2 equals 2. And so what does that mean? 4 divided by 2 equals 2 means that this 4 is 2 times greater than 2. So the units on the top are 2 times the units on the bottom. So that 4 is equal to 2 times 2. So this 4 is equal to 2 times this 2 right here. Now that's a little bit confusing because it's 2 and 2. So let's use something different. How about 7/3 is equal to 2 1/3? So what that's saying is that 7 is 2 1/3 times greater than that 3. Or the number of units for the 7 is 2 1/3 times the number of units for the 3. So 7 divided by 3 equals 2 1/3 means that 7 is 2 1/3 times greater than 3. So that's 7, this 7 right here, is 2 1/3 times greater than 3. So it's 2 1/3 times 3. And that makes sense. 2 times 3 is 6. 1/3 of 3 is 1. 6 plus 1 is that 7 right there. So let's do something a little bit weird. What if we just said 7/3 was equal to 7/3? What would the language tell you? And can I prove that to you? I'm going to make a drawing that does prove that to you. So what this says is that 7 divided by 3 equals 7/3 means that this 7 is 7/3 times greater than 3. So this 7 right here is 7/3 times greater than 3. So you can take that 7 that equals or is 7/3, that's 7/3 times greater than 3, or times 3. So a drawing of that, let's draw 7 squares and identify the 3, which is the third square. So now we're going to look at thirds of 3. 1/3 of 3 is one of the squares, 1. 2/3 of 3 is 2. 3/3 of 3 is 3. That's the same as 1 times 3. Okay, now if you go past that, 4/3 of 3 is 1 1/3, or 4. So this is one group of 3, and then 1/3. So this is 4/3 of 3 is 4. 5/3 of 3 is 5. Now notice that the 3's all cancel. 3 divided by 3, 3 divided by 3, 3 divided by 3. 6/3 of 3 is 2 equal groups of 3. 6/3, 6 divided by 3 is 2. 2 times 3 is 6. So this is one group of 3. This is 2 groups of 3. So 6/3 of 3 is 6, or 6 divided by 3 is 2. 2 groups of 3. And then finally 7 is 7/3 of 3. So this 7 is 7/3 of that 3. So here's 3/3 of 3, 4/3, 5/3, 6/3. 7 is 7/3 of 3. So hopefully that helps a little bit. Continue to think about it, and we will continue to go over this a lot. This is the summary for lesson 4. And in the summary, they show you this table, and they're going to use red paint and blue paint to make a color, a shade of purple paint called Venusian, I guess you pronounce that, Venusian sunset. And so they're going to make the blue paint the y value and the red paint the x value. So y over x, you need to figure out the constant proportionality. So I'm given a certain amount of red paint. What do I multiply that red paint by to figure out how much blue paint I need to use to get this shade of purple? So blue over r, y over x, same as blue b over r, and use one of the rows. Doesn't really matter which one you use. 12 divided by 3 equals 4. So what is that telling you? Well, the units of blue paint are 4 times the units of red paint. So the units of blue are 4 times the units of red. So blue is equal to 4 times the units of red. So blue right here is equal to 4 times the units of red. So whatever I'm given in red, I have to multiply that by 4 to get the amount of blue paint. And down here in the text, see the same thing. Blue is equal to 4 times the units of red. On the next page, they switch the columns and they say, well, what if they give you the blue paint and you have to calculate the red paint? So now they're going to say that the red paint is y and the blue paint is x. So they're just switching the columns. So they're going, it's like going the opposite direction. So it's as if I'm going from the 4 to the 1 or the 12 to the 4. Well, to do that, you might remember that you use the multiplicative inverse or the reciprocal of 4 to go in the opposite direction. All right, so now we're going to set this up as y over x once again. So this is 3 now is the red paint, 12 is the blue paint. You set that up. So y over x is red over blue, so that's the reciprocal of the last table. So 3 over 12 is the same as 1/4, and so what's that telling you? The units of red paint are 1/4 the units of blue paint. So if I'm given the blue paint, I multiply that by 1/4 to get the units of red paint, because the units of red paint are 1/4 the given amount, which is the units of blue paint. So the units of red are 1/4 units of blue. So now you're going in the opposite direction. So really you're using the multiplicative inverse of the previous table. Remember, that's called the reciprocal. So it's 1/4. Red is equal to 1/4 blue. So the units of red paint are 1/4 the units of blue paint. Remember, this came from R. This B was over here. It was R over B, and then we can move that over here because we can say that the units of red paint are 1/4 the units of blue paint. And it gets down here where they, and finally you can check that by multiplying each one of these by 1/4. And you see that they all work. 28 divided by 4, 28 times 1/4 is 7, 1 times 1/4, 1/4, 4 times 1/4, 1. And we're going to move to this general equation. Y is equal to kx. So y is equal to k. K is the constant of proportionality times x. It's the equation that shows up every single time for a proportional relationship. So we're going to start moving in that direction. And I'll come back to that. I'll remind you of this, but why k? Because in German, when you write constant, you spell it with a k. So that's where that k comes from. So y is equal to some constant of proportionality times x. So we calculate the constant of proportionality, and we can figure out the amount of y, which is the right column, based on a given amount of x, the left column. So we're going to move from the x to y by multiplying by k. So we do that all the way down here. That's what we're doing. Let me just zoom in on this just a little bit because it's a little bit small. So the number of units of red paint are 1/4 the number of units of blue paint. Units of red are 1/4 units of blue because it was y over x. It was red over blue, and that was 1/4. And again, that's the multiplicative inverse or the reciprocal. So if you use 1/4, the units of red paint are 1/4 the units, the given units of blue paint. Hey, I have 12 pints of blue paint here. How many pints of red paint do I need to make this shade of purple? Well, you need 1/4 the amount of blue paint you have. So you need 3 pints of red paint to make that shade of purple. Okay, these are the practice problems for lesson 4. And in this first problem, you're given ceiling tiles. Their ceiling is made up of tiles, and they measure the area of the ceiling as every square meter of area requires 10 7/75 tiles. So we're going to call the tiles T, and we're going to call the area of the ceiling A. So the square meters of the ceiling is A, and the number of tiles that you need to cover that area is going to be T. And so they have to give you one row, and they do that actually in the words up here. They say that for 1 square meter, that you need 10 7/75 tiles. So they're giving you the constant of proportionality right there, because this is y is the number of tiles, x is the area, so y over x is the same as t over a. So y over x is the same as the number of tiles per area. And they tell you that the number of tiles per area is 10 7/75. That's what these words right here tell you. So what does that say? It says that the tiles are 10 7/75 times the units of area. So units of tile are 10 7/75 times the units of the ceiling or the area. So that means that the number of tiles is equal to 10 7/75 times the area that you have to cover. So I have to cover 10 square meters. How many tiles do I need to cover that? You need 10 7/75 times that 10. So you would need 107 5/10 tiles. And that equation is down here. We wrote that equation up here. I'm going to skip this row just for a moment. That equation, we wrote it up here. So, but the number of tiles, this column, y, or t, is 10 7/75 times the area. So the number of tiles is a number that's a lot bigger than the number of square meters of area that you need to cover. If you go the other way, I have 100 tiles. How much of the ceiling can I cover with my 100 tiles I happen to have? Well, now you use the reciprocal of 10 7/75. So that's 1 over 10 7/75. So you divide by 10 7/75, multiply by 1 over that, same as dividing. So 100 divided by 10 7/75 equals 9 3/10. So I need 9 3, with my 100 tiles, I can cover 9 3/10 square meters of ceiling. And that makes sense. This is a little bit less than 107. I could cover 10 square meters with 107 tiles. I have fewer tiles, so I can cover lesser area, but not by much. 9 3/10 square meters versus 10 square meters. Problem number 2, an airplane is flying at a constant speed, so that's going to be the constant of proportionality, from New York to London, and they tell you that they give you this equation, so they're giving you the relationship. So time is equal to 1/500th the distance traveled. So this is time over distance. So remember that the distance used to be over here, and it was time over distance was equal to 1 over 500. So the units of time are 1/500th the units of distance. So the amount of time that you travel is going to be a lot smaller number than the number of miles you travel. That makes sense. You travel 800, 900 miles in a few hours. Okay, the units of time are 1/500th the units of distance. So then you can rewrite that as time is equal to 1/500th the units of distance. Well, they give you the units of distance. They tell you it's 800 miles. So time is equal to 1/500th of that 800. That's 800 over 500, which is the same as 8/5. You have 800 of something over 500 of something. That is the same as 8/5. And it's 8/5 of an hour. Well, that's 1 hour, which is 5/5, and 3/5 of an hour more. 3/5 of an hour, 1/5 of an hour, and 1/5 of 60, or 60 divided by 5, is 12 minutes. 3 times that 12 minutes is 36 minutes. So it's 1 hour and 36 minutes. So y over x, miles, 1 over 500. So it's 1/500th an hour per mile. So they set this up as hours per mile. Usually speed, and they say speed up here, speed is actually written as miles per hour. So they set it up the opposite way of what they're telling you. They're actually giving you the pace of the plane, which really doesn't make any sense. No one talks about pace. But just be aware of that a little bit. So miles per hour, this would be 500 miles, or the number of units of miles is 500 times the units of hours. So 500 miles per hour. And you don't really have to worry about this too much. Just pay attention to what's going on here. Okay, problem number 3. Just says, find the constant of proportionality and write an equation for each of these. So this is the y column. This is the x column. So nothing changes. The constant of proportionality is y over x, which in this case is going to be this capital P over s. So P, and this is perimeter, and this is the side length of a square, is what they're showing you. So P over s is equal to 8 divided by 2. You can use any of these as to figure that out. They're all going to equal 4. So what's that tell you? It tells you that the units of P, or the perimeter, is 4 times the units of the side length, or s. So P is 4 times s. So P, the perimeter, is actually equal to 4 times the length of the side. So the constant of proportionality is 4, and the equation is that the perimeter is equal to 4s. And that really comes from right here. Get used to saying this once again. So the perimeter, or P, is 4 times s. So then you just write it. P is 4 times s. Same thing over here. This is the circumference of a circle. This is the diameter of a circle. So it's saying the circumference is going to be y, and the diameter is going to be x, or c, and d. So nothing changes. It's the same thing. Constant of proportionality is y over x, is that c over d. And if you do that calculation, take c and divide it by d, divide it by 2, that equals 3 14/100ths. So 6 28/100ths divided by 2, 6 divided by 2 is 3, 28 divided by 2 is 14. So what does that tell you? It tells you that the units of c, or the circumference, is 3 14/100ths times greater than the units of d, or the diameter. So c in the circumference is in fact 3 14/100 times greater than the diameter. So the units of c is 3 14/100 times greater than the units of d. So here's the equation. C is equal to 3 14/100 times d, and the constant of proportionality is 3 14/100. Problem number 4. A map of Colorado says that the scale is 1 inch to 20 miles, or 1 to 1,267,200. Are these two ways of reporting the scale the same? Explain your reasoning. When you don't have any label, it has to be the same units. So if this is 1 to 1,267,200, it's going to be 1 inch to 1,267,200 inches because it's 1 here. So are they the same? So is 1 to 20 miles the same as 1 to this number here, 1,267,200? All right, so don't forget what you know. We did this a while ago. There are 5,280 feet in a mile, so somewhere you have to know that. Look it up, figure it out, because I don't think it's given to you anywhere else in these pages. So 5,280 feet per mile, that is the constant of proportionality. So miles are big, feet are small. So you're going to need a whole lot of feet to equal 1 mile. So this makes sense. You need a whole lot of feet to equal 1 mile. So this is the constant of proportionality. So you can use that. 5,280 feet now is the 1 mile. And how many inches are in 1 foot? There are 12 inches in a foot. So I've moved from figuring out how many feet are in a mile. So now I need to figure out how many inches are in a foot. I have to multiply that by 5,280. There's 12 inches in a foot. That's the constant of proportionality. So feet are big, inches are small. So you're going to need a lot more inches to cover 1 foot. So feet to inches, more inches. So you're going to multiply by 12 to change this number of feet to the total number of inches. 5,280 feet times 12 inches is 63,360 inches in 1 mile. But how many? And this is the constant of proportionality. And again, inches are really, really tiny compared to miles. So you're going to need many, 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 many inches to change this to miles. And how many miles you have? You have 20 miles times 63,360 inches in every 1 mile. So you have to multiply it by 20. And guess what that gives you? 1,267,200 inches. So yes, they are the same scale. And the last problem, they give you this polygon, and they say draw a scale copy of the polygon with a scale factor of 3 and label it A. So this is A, right? I forgot to label it. This is A right here, a scale factor of 3. That means that every length is multiplied by 3. So 3 times 2 is 6. This is going to be 6 by 6 by 6. And I just drew another square the same size and connected them in the middle. And so this is 6 units along here, 3 units up here. So this length is in fact 3 times this length. All right, so scale factor of 3. And draw another polygon with using a scale factor of 1/2 and label that B. So this is B, a scale factor of 1/2. So each length is going to be multiplied by 1/2. It's going to be half the size. So this is 2, this is 2, 2, and 2. So this gets reduced down to 1, 1, and 1. Then I just drew another square and connected them in the middle to make these lengths half of these lengths. All right, so now to go from this small polygon to this polygon, you multiply by 2. So now you're going back in the other direction. So you're using the reciprocal or the multiplicative inverse. And then remember to go from this polygon to this polygon, you multiply by 3. When you multiply by 2, then by 3. 2 times 3 is 6. So those two steps together equal a scale factor of 6. So what's the scale factor that takes B to A? B right here to A is a scale factor of 6.